Hi, I'm Ben Heck, and today we're going to talk about 3D printing. Okay, so this is a MakerBot replicator. This is the first replicator that MakerBot made, but it wasn't their first 3D printer. They'd been making 3D printers for several years before that, but this is kind of their first mass market one. I first saw this at CES in 2012, I think, which would have been January 2012. And I was very impressed because it wasn't a tablet or a 3D, what was the fad back then? 3D TV was a fad that year. Anyway, yeah, it's made of plywood, but it actually holds up pretty well. I've had this about not quite 2 years. I have 628 hours on this particular unit. And all I've really had to do is fix a wire here and tighten the motors because they do come loose eventually, which means it'll start printing. It'll make circles that aren't quite circle and whatnot. Circular. Circles that aren't quite circle. Anyway, one thing, this has a heated bed. They're kind of getting away from that because they're kind of getting away from ABS, which is a type of plastic. And one thing that I don't really like is it actually takes longer to heat the bed than it does the extrusion nozzle, which kind of seems counterproductive. In fact, it often takes longer to preheat or heat up than it does to print something if you're printing something small. But you know, that's a minor quibble. Other than that, no regrets, worth every penny. And I got it for a discount, so it was worth even more than that. It was actually a discount plus 2 free filament rolls. So this is the filament. And you might say, hey, that looks like weed whacker material. And you know, I bet most of the early 3D printers did use weed whacker material. This is ABS. ABS stands for a chemical that I can never remember. It's like, I'm not even gonna try to pronounce it. Something, I think the last word is styrene though. And so ABS is basically the kind of plastic that anything would be made out of. This would be ABS. That's steel. Your Xbox is made out of ABS. And yeah, you can tell the difference. I always just taste it. I taste everything. So if you taste if I'm not eating it. Okay, it tastes kind of like waxy, or it's not like chipping in my mouth, which means it's ABS. The other type of filament they often use with these is called PLA, which I do know what that stands for. It's polylactic acid. It's organic, I believe it's derived from corn. And it prints at a lower temperature and it's organic, which means it can biodegrade in the sun. I'm sure it takes quite a long time. A milk jug allegedly will biodegrade in the sun too after 100 years. Anyway, this tends to contract. It doesn't have as a good dimensional stability as the PLA, but the resulting print is stronger. So I mostly use ABS because the stuff we build, we don't just build things that just kind of sit there like, oh look, it's a pretty 3D printed butterfly. We're building things that you put screws into or that you put into mechanical assemblies. So things that actually do need to have some strength. Anyway, so the heated bed is not necessary, but very helpful for making ABS stick, whereas PLA filament, they usually print that without a heated bed. Anyway, the bed gets to about 110 Celsius, and the head of the extruder is around 215 Celsius, I believe. It's pretty normal. So what I'm doing right now is I'm just preheating it, so as soon as I hit print, it will immediately start. So the software that I'm using is the MakerBot software. You download it from makerbot.com. I think it's called Makerware. It used to use a more open program called Replicator G, which is kind of a standard program that you can plug into any printer. But after the first couple years, Makerware became mature enough that it's actually usable. It has quite a few options as well, which is nice. A lot of the out-of-the-box printers, the interface is, well, for lack of a better word, really dumbed down. This one is pretty good. I'm actually going to print extruder gear for another 3D printer here. So what you do is you get an STL file. STL is a type of file that you put into a 3D printer. And STL stands for two different things. It either means stereolithography, which is a type of 3D printing that this isn't, or STL also sometimes is, well, what it technically is surface tessellation language, basically a description of all the triangles that make up this mesh. So this thing, for instance, it's pretty simple. I just make sure it's on the table, which it is. And if the file isn't flat on the table, it'll tell you. I can move it around. I could make 2 of them if I wanted. It's pretty simple. We hit make, and there's quite a few options. I mean, we can have fewer options, but I'm gonna print this actually at high quality. And these settings, infill is how much latticing it puts inside of it. Most 3D prints aren't solid because if they were, they would take even longer. They're usually kind of hollow with support structures. So infill percentages is how much support structure it makes. 10 is pretty normal, 15 is above average. And since we're gonna be making a gear that's going to hold weight, or torque, I should say, I think this higher option should be good. Layer height is also like the vertical resolution. You may have heard people say, oh, this machine can print with 100 micron accuracy. So 100 microns is also 0.1 millimeters. So yeah, that's pretty good. So yeah, I think we should be good here. You can have a raft to make it stick better. Supports is if it overhangs, like if you printed an arch, it might have trouble. So it'll actually print like a lattice, very much like scaffolding, to help support things that might otherwise fall down. But as a general rule, you want to design things to not need supports unless you absolutely have to, because I just consider that good design practice. So the software is slicing the file, which means it's taking the 3D object and making, I don't know, probably about 60 or 70 layers. So it's kind of really, it's like many 2D layers stacked on top of each other, or slices, and it does them one at a time, moving the head up, creating the object. While that prints, I can show you my junk bin. If something prints successfully, but I don't need it for anything, I put it in this bin. And when people come to visit, I've always got basically 3D souvenirs, because a lot of people, they've heard of 3D printing, but they don't understand it. Although I've noticed people seem to figure it out pretty quickly. They're like, oh, I get it. My favorite comment was actually from my mom, who is one of the least tech savvy people you ever meet. But, so she was visiting one time and she saw my 3D printer, and I explained to her how it works, and she's like, oh, it's just like in Fifth Element when they put the woman back together slice by slice. And I'm like, yeah, that's exactly right. So I was impressed she made that correlation. These are actually from a project we're doing right now, which is the Minecraft logic cubes. These are test prints. What I do is I'll be sitting there at my desk and I'll design something and I'll print it. And I'll just design enough just to test it out and then immediately print it. Because if you spend hours and hours designing something and then print it and then find out it doesn't work, you've wasted a lot more time. So I'll just print very small iterations. I mean, you can print this in like 5 minutes. This piece was left over from, I don't know what that's from. That was either from the scanner episode or the desk lamp that I made. These were from the camera rig. See these PFTE sliders, that's what went on the tube. So this actually went back and forth. This was, I don't know what this was for. It was obviously for a timing belt of some kind. This was a piece from the hot glue gun, another prototype. Here's a bracket. That's PLA. We never used that, whatever it was for. If people stop by the shop, kids and adults, they always enjoy, taking home a piece of 3D printed something. It's like, I've heard of 3D printers. It's like, want something 3D printed? This is way over engineered. This was a vertical up kicker. We used this in a pinball machine prototype. This was in my prototype Ghost game for, oh God, at least a year. And see, I went really over, it was like 1/2 inch thick everywhere. This probably took about 4 hours to print. And then it looks shiny because I coated it with acetone, which is a solvent that will eat ABS. So what you do is if you basically paint something with ABS, all the little layers get bound together even more than they already are. and you can improve the strength. This, I couldn't break this if I tried. But even this, it's not completely solid. It doesn't look as heavy as, I mean, if this was solid plastic, it would weigh a lot more. But yeah, this has a crosshatch infill. Actually, let's see if, let's get something here and break it so you can see the infill. So you see the way the layers go that way? So if we break it this way, we should see some infill. Actually, let's use this. So yeah, the unit's not solid. It has a couple walls and then it has a crosshatch. It depends on, you know, what piece is where. Yeah, so that's what a 3D print looks like on the inside. And now those pieces are garbage. I guess you could recycle it, but I would need like a chipper. There are people who take this stuff and, well, it's kind of in its infancy, but you can chip it up and re-extrude it into filament again. Although it's kind of a lot of work, but it can be done. So yeah, 3D parts bin. Hey, look at that. Wow, 3D printers are great. I made a gear. This is actually a gear for making another 3D printer. This is what will drive the plastic extruder. If you want to learn more about 3D printers, go to element14.com/3D printing. If you enjoy this behind the scenes footage and want to see more, please let us know by leaving a comment below. And don't forget to subscribe.